So, hopefully today, friends, you had a review of multiplying with zeros or multiplying powers of 10. Expressions, and I'm just reading this from your page 119 from your book, and I want to go over some vocabulary words so that we have a good understanding. And I'm going to box some things that would be helpful for you to have in your notes. You don't have to have all of this, but some things would be really key for you. Expressions with repeated factors, such as 10 times 10 times 10, can be written by using a base with an exponent. So the base is the number that is used as the repeated factor. In this case, it would be the 10, okay? The exponent is a number that tells how many times the base is used as a factor. So if you write down this example right here with these labels, you'll have a good picture of what we're talking about. So if you need to pause it right now, write those two sentences, and then you can press play to continue forward. When you represent a number using a base and an exponent, you are using exponential form. So if you were to write exponential form, this is what exponential form would look like. Word form, you know what word form means. 10 raised to the third power, or the third power of 10 is how you would read this right here. So I want to do some examples with you with this. I think you're going to get the sense of the pattern the more of these we do. But if I were to write each of these expressions as a repeated multiplication and solve them, what would it look like? Well, 10 to the second power, 10 times 10 would equal 100. 10 to the fourth power, 10 times 10 times 10 times 10 would be 10,000. Hopefully you're starting to see that. 10 times 10 times 10 times 10 times 10. 10 to the fifth power. 1, 2, 3, 4, 5 is 10 to the 1 power equals 10, which equals 10. So when you're starting, this is what exponents represent how many times that base number that you're going to do. And this tonight, we're only doing powers of 10. So it makes it a little easier. So if I were to rewrite this expression on number 49, I would say 5 times 10 to the second power, because there's 2 10s. If I would say 9 times 1, 2, 3, my base number is 10, 3 times. 3 times 1, 2, 3, 4 is 10 to the fourth power. 2 times 10 would be 2 times 10 one time. 1 times 10 to the second power. 7 times 10 is my base. 1, 2, 3, 4, 5 to the fifth power. So hopefully you're starting to see that pattern. So if we were to multiply by a whole number, a power of 10, what would that look like? So I'm only going to do a few of these, and hopefully we'll start to actually, some of you, the light bulbs are probably still on. Please include these examples in your notebook so that you have it as a reference. So if I were continuing this pattern, 3 times 10 to the first power would be 3 times 10, which equals 30. If I was doing 3 times 10 to the second power, it would be 3 times 10 times 10, which is 300. Remember, I want to see if you can make that connection from what we did in class today, from our 4th grade multiplying with zeros to 5th grade. 3 times 10 to the third power is 3,000. 30, now you've got 30 times 10 to the third power. You've got this right here, which is 1,000. You've got this right here, which is 30. So you have 30,000. So what pattern do you see? I'll let you think on it. Pause if you need to. The pattern so here's a sentence that sums up, I think, the pattern that you're seeing. The numbers of zeros in the product, which is our answer. Let's go with this. This is our product here. The number of zeros in the product, so we have 1, 2, 3, 4 in this example, equals the sum, if you're adding all those zeros together, of zeros in the power of 10 and the number of zeros in the other factor. So in this case, here's my power of 10. I have 3 zeros here, 1, 2, 3, plus the zeros in the other factor. Here's a 0 in the other factor. So how many zeros do I need to have in my product? That's right, 4. So let's test this theory on a couple of examples that I have going on down here. Find the value. So if you were looking at 1 times 10 to the 4th power, how many zeros do you think that there are based on our pattern that we've already found out? I think I hear you saying it. There should be 4 zeros in your product. What about 2 times 10 to the 3rd power? How many zeros should there be? I hear you. 3 of them. Now, 62 times 10 to the 2nd power. I heard you. 2 zeros. Nice work. So we're going to do 2 more. I think you're starting to see this. So this could be, I think you're catching on here. So 7 times 10 to the 1st power equals 7 times 10, which we know is 70. 7 times 10 to the 2nd power, this right here, we know equals 100, which we know equals 700. 7 times 10 to the 3rd power equals 7 times 1,000, which is 7,000. 7 times 10 to the 4th power, 10 to the 4th power equals 10,000, because there's 1, 2, 3, 4 zeros. 70,000. 4 zeros, 4 zeros. So let's try this again. Now, over here, you're going to complete the pattern. So you're going to be filling in this part over here. So 9 times 10 to the 1st power is also 9 times 10. 9 times 10 to the 2nd power is 9 times 100, because we know that 2 means 2 zeros. 9 times 10 to the 3rd, we know 10 to the 3rd is 1,000, and 10 to the 4th is 9 times 10,000. There's a 4, 1, 2, 3, 4. There's a 3, there's 1, 2, 3. There's a 2, 1, 2. There's a 1, there's 1. 1, 2, 3, 4. So I hope that you have kind of a better understanding of multiplying, using exponents to represent and multiply powers of 10. We are going to continue with this for a few days. Make sure you have these examples in your notes, and we will talk some more tomorrow.